Welcome, applicants. It's 21st of April, and Alessio and I are here to tell you about the courses in the School of Engineering. That's the school. The division is called Mechanical Engineering Design, and you should all have an offer from UCAS on one of the courses, which I'll relate to later on. I put my email address down there because I'm more than happy to have emails from applicants about what they're interested in, what they're concerned about, in order to put their minds at rest. It's a big decision you're making. Where you go to for the next 3 or 4 years, 5 years if you do a master's course with a placement year, and therefore you've got to make sure you're happy with the resources, the ambition, the content of the course that you're coming on to. Yeah. So I'm more than happy to have emails from applicants. Also, we've got 2 Instagram accounts on the bottom right down there. We've got the Product South Bank for the more design courses, and then at LSBU MEchEng for the mechanical engineering courses. So I'm going to move on to the next slide. No, I'm not. Yes, I am. What's gone wrong here? Okay, Alessia, can you see School of Engineering and the 4 divisions?
Yes, I can.
Fantastic. So a bit of context. So the university itself has got 6 schools: business, health, applied science, etc. The course you've applied for is in the School of Engineering, and that school is broken down into 4 divisions: chemical, computer science, electrical, and mechanical engineering design. And of course, that's the best one. Alessio is head of division for the Mech Engine Design course, and I'm an associate professor within that division. Bit of background. So we have a good history of both teaching and research. So in 2014, we were the #1 modern university in London for research. Going back a few years, we were the first in the UK to admit women into engineering course. So you can see how we've got a wide range of being inclusive and also having high standards. And in 2016, we also were rated in the top 10 of teaching quality and student experience. And we'll come back to that Sunday Times league table a bit later on. So there's an image of some of our students in the workshop. Khadija on the right-hand side is now an entrepreneur in her own right. We sadly don't have 50% women on the course, as we should do, because there's 50% of women in the population. It's probably near about 25% for the design courses and maybe about 10% for the engineering courses. But we are very keen to bump that level up as high as possible until we get to 50% and parity. The university is also known as being an enterprising university. So in 2016, we were awarded the Entrepreneurial University of the Year award by the Times Higher Education award system. And we actually have on campus, we have an incubator called the Clarence Centre, where some graduates will go and join that incubator and actually spin a company out based on either their major project or an idea they've had for an enterprise. And throughout your years 1, 2, and the final year, there'll be input from the enterprise office into your course, either guest lectures or seminars or workshops, which you can access free of charge. I mentioned I'd come back to the Sunday Times Good University Guide. The reference I gave you previously was 2016. We had the 2020 league table released last year, and this slide came from marketing, and I was a bit disappointed because computers got 3rd and Eleceng got 1st, etc. in London. There was no mention of mechanical until I got to the last slide, where a great result. We actually had a #1, first of all in the UK, so we're best in the UK. We also had 2 #1s. We were rated 1st for teaching quality, so that's like people, Alessio and I, waving our hands around, writing exams and doing setting coursework for you. We were also rated #1 for student experience, which in my eyes implies that the students actually enjoyed going to our lectures, doing our coursework, seeing what guests we brought in for talking to them, etc. So I think this is a good reflection on that we do put the students first and foremost. Okay, so here's your first chance for the chat channel. What I'd like you to go and do is put in the chat channel which of the courses you've actually applied to. So here are all the courses that we're running at the moment. We're running a BEng and an MEng in mechanical engineering, and that runs both full-time and part-time. We're running a BEng and MEng in advanced vehicle engineering. That's also running full-time and part-time. And those two streams are accredited by the Institute of Mechanical Engineering, the IMechE. We run a one-year top-up course, which is non-accredited. You can't accredit a one-year course with anybody because it's not long enough, it has to be 2 years. And that's called BEng, Mechanical Engineering and Design. And they join us just for the final year of both the BEng, MEchEng and BSc Engineering Product Design. And the two courses at the bottom are our two design courses. They are both BSc honours, so not BEng, but BSc, and they're accredited by the Institute of Engineering Design as the IED, and that's BSc Engineering Product Design and BSc Product Design. As I mentioned before, you'll see there's like a spectrum of courses running from the more highly mathematical ones, the MEng and MEchEng at the top, and perhaps the less mathematical. In fact, there are no exams on BSc Product Design. It's all about coursework, problem-based learning, producing presentations, etc. That's just a reference. That is the one course we don't accredit because we can't. That's on the rest of them are accredited, allowing you to become either incorporated engineer, chartered engineer, or chartered technological product designer. I'm going to use the W5H2 technique in my next few slides to explain the who, the what, the where, the whys, and then the how-to is what your next step should be if you like what you see on screen. Yeah. So there's the 5 W's: where, who, what, when, and why. And next one is the how-to. So first of all, we're not sure where you're from because you've dialed in, but certainly we know where we are. We're in the slap bang in the middle of London. Some of us have got the view of the Shard from our office window. Yeah. So we're in Zone 1. We're just south of the South Bank Centre. Elephant and Castle Tube Station is on our campus, so we're in Oxford Circus by about 15 minutes. So anywhere you want to get to in London is easily accessible from the university. In fact, there's a map of it. Can you see my cursor, Alessio? It's hovering over the university.
I can indeed.
Excellent.
It's visible. Yeah.
So those of you who watch EastEnders will know there's a wiggly line in London. That's the blue line, the Thames. And over this way somewhere is Albert Square. Yeah. In real London, there's Waterloo. Yeah. And Covent Garden. And we're over here, South Bank University. So you can see we're a short walk from Parliament Square and Big Ben, and over to Trafalgar, Buckingham Palace rather. Yeah. Ditto a short walk through Hungerford Bridge into Covent Garden, or over Waterloo Bridge into the other areas, or ditto if you want to see London, we're over here. So we're incredibly centrally located. So there's lots to be offered as a student. London is a world capital. It's an exciting place to be, lots to get on there. Sure, it can be a bit dirty and a bit messy and a bit unfriendly at times, but once you get yourself settled, you've got the whole of London to go and look at and actually learn from. We're very close to the South Bank Centre, so that's got the BFI IMAX, Tate Modern, Festival Hall, Hayward Gallery, so loads of things for your artistic side to go and be enjoyed by. If that was the where, this is the who. We have a load of international students, so 130 countries and counting, and ditto, we have a load of international staff as well. So we have students who from a very wide range of backgrounds. We're known for having mature students, so you're including people who are older than you, who are choosing to have a career change, different backgrounds and qualifications. So it's very much a multicultural student body. Yeah, we're very hot on equality and diversity. we want you to use our course to get trained up and go on and do great things when you graduate. And we believe you could all go and do that and learn a lot while you're with us. And the same really applies to the academic, technical, and admin staff at the university. They also come from a different range of backgrounds, different nationalities, different interests, etc. And most of these staff are also, on the academic side, active in what's called research and enterprise. And this is what separates out the universities from the further education colleges, because universities are always active in research and enterprise. So I'll spend a few minutes just talking about how that affects you, but this is where the PhD scholars and the research are actually looking at different areas which can then trickle down to the undergraduate courses or the postgraduate courses. So we have research centres, energy engineering, cognitive systems, and also bioengineering. And I mentioned enterprise before. We have an active research centre looking at how to get engineers to be more enterprising. Sorry. And these all give us what's called research-informed teaching. So things that are heard about in the research labs are then brought to the undergraduate course, like novel coatings or novel foods, etc. We have a colleague who's looking at the bending of very thin rods or almost cat's whiskers and how that could be used in maybe cleaning wind turbines. Yeah, a colleague looking at the material properties of ice and how that will be affected by global warming. If you go right to the bottom of that slide, you've got a thing called the Human Powered Vehicle Project, which is AIM 93. I'm going to show that on because it's it's very visually understandable about what it is. In essence, it's a staff-student project to build and race the world's fastest bicycle. So we've calculated this thing can go at 93 miles per hour. Yep, that's right. And you can see there, in essence, it's a elongated mango shell of a cover encasing a recumbent bicycle. It's raced over at Battle Mountain in Nevada in the World Human Powered Vehicle Manufacturing race championships. We haven't got to 93 just yet, but we're going to get there as we get more experience, etc. But theoretically, that's what our computational fluid dynamics will be able to go and analyze it too. Alessia, could you put a93.com in the chat channel just so they've got a vision of that one?
Will do.
What's exciting about that is that the software used in that is available to the students as well. So we are a Autodesk, that's the company that makes AutoCAD, we're an Autodesk Lighthouse account. And you'll be trained on Fusion 360, which is a three-dimensional parametric modeler from year onwards, year one onwards. And that's exactly the same software that was used in the construction of AIM 93. So this is the internal seating buck. This is where the rider would sit with their back on the over here, and then the boss for the axle for the front wheel coming over there. It's also the same software that was used to go and drive this KUKA robot to go and mill out the side panels for the molds for the vehicle. Here you can see almost a small version of that mango stone I mentioned. That's going to get bigger and bigger as the robot arm comes down. That's our colleague Glenn, who's sadly retired now, but the project lives on. And this was all done on site with what's called the DAR lab, the Digital Architecture and Research Lab, which is one of our sister schools research centres. So again, we're collaborating with different schools to go and build things best of all. You've now got on the top line 3 images in green. The middle image is the CAD image, which has got the branding and the logos on it. The images to the left and right are the actual prototype. And one of the innovations we did have was to have a little stabilizer wheel that would come out and stabilize it as it reached before it reached top speed. As you might imagine, on a bicycle, it's very wobbly when you're going at low speed. The rider here can't put his leg down because actually he's all encased. Yeah. So the idea is they start off with just that little wheel going. When it becomes fast enough, it's retracted in there. And that was a bit of an innovation. On the left-hand side, you've got the Rockingham race course where it was tested. And these 5 rather bone-like structures are what's called generative design. again, this is probably a new thing to most students. This is where the software can suggest new ways of linking key points of your device. So in this case, we put in the size of the rider, we put in where the pedals had to go and be, but then we let the computer work out how it could connect itself to other parts of the chassis. Yeah, we know they look like bones, these things, and they couldn't be made in perhaps normal manufacturing. But as we get more advanced with additive manufacture and 3D printing and 3D metal printing, this maybe could be made from a carbon fiber printer. And you're getting a very, very lightweight structure that is incredibly tuned to the to the function. That was the wrong one, ignore me there. And there we have the actual full-size bike. So there's Glenn again, here are the student body. There's the little wheel I talked about, yeah. And there's the scratching proving it's been tested, yeah. So any good design or engineering project, you analyze, you build, you prototype, you then test it and work out what was right, what was wrong, yeah. It looks like here this thing got dropped going around a corner of some sort, and therefore how could that improve for the next run. So that's the research project. Where's the trickle down that I mentioned? Here it is. So from the expertise we had of that recumbent bicycle, we set a first year project for the engineering product design students and product design students to go and build a recumbent bike within 2 weeks. We gave them each a couple of what's called rescue bikes. The bikes you see outside the station have been anchored there for 2 years and forgotten about. They get collected, and we ask, can we use those ones? We gave them a run of bamboo and also some carbon fiber technology about how you might bond bamboo together. So that became the structural force of it, and they were then going building first a full-size card model and then a full-size working rig, which they then tested. So it's a great way of actually looking at going from research down to teaching. I mentioned the workshops a few times. We are very well equipped with workshops. So if you like making things, you're in the right place. We've got metal machine shops, we've got wood workshops, we've got soft material workshops, 3D printers, electronics, everything. Yeah, and these things really do develop the practical skills that employers value when you're out there in industry. You can go and make things. Lots of learning happens in the workshops. So here you've got Ben Clark on the left-hand side, one of our colleagues with a furniture design project. And you can see in front of them a series of card models, even getting up to full-scale card modeling. You start to work out what can and can't work. Things that work wonderfully on a piece of paper won't work in real life because they can't turn the corner or whatever else. And therefore, it's important to get into full-size modeling as soon as possible. Ideally with the right materials, but that might take too long if it's wood, a lot quicker maybe if it's a softer material. So that's a shot of the wood workshop, which we took over for the bike project. I see the students hacking up their bikes and building things. I mentioned the CNC robot arm. We've also got some CNC mills and lathes. Again, the software you use will drive these machines. Obviously, it's a bit more serious because you're cutting into aluminium, etc., and therefore probably more for project work than just for the interest in there. But that's part of the metal machine shop. For the advanced vehicle engineering course, we have a dynamometer and a test cell where you can go and look at engine performance and torque curves. And Ravi, who's our colleague on the right-hand side over here, is the course director of the B-Eng, Mech-Eng, and the advanced vehicle course. So all the data you get out of those dynamometers, you're then analyzing that. So we also teach you about object-oriented programming. We teach you about MATLAB, how you might use data and analyze it to go and get, an interesting point about a certain sweet spot of the torque curve or a certain improvement on the piston or the electric motor. So yes, we like people who make things, who want to make things better, aren't afraid of taking things apart, analyzing them, looking at the physics behind everyday life. So that was the where. The what is the how we do it. So we break your course down into what's called academic modules. And these are given a credit point of either 20, 40 or 60. And every year you have to get 120 credits to move from year 1 to year 2. We do have a sandwich year option. That's where you have an industrial placement and you go and work for a year. This is normally in your 3rd year. And there's no fee for this year. So when you are a fully enrolled student at the university, you're charged your student fees of £9,250. On the placement year, there's a big fat 0 for your fee. And that's because we know you'll learn lots and come out a much better engineer or designer because of it. Yeah. If you do 3 years of study with us, you'll end up with 360 credit points and you get yourself a bachelor's honour. So either a BSc honours or the BEng honours. If you go for the MEng in mechanical engineering or advanced vehicle engineering, you do an extra year and have 480 credits. And all of the courses end with the major project. A lot of the pictures I've shown you are the major project where there's a lot more time about thinking about it, which is almost your flagship out from university into industry. Now, really the important bit is actually the course content. So I mentioned about those credit values. I'm going to talk a bit now about the course content. Alessia, were there many product design or engineering product design students on the chat channel? Do you know?
Strangely, Robin, I didn't get any replies.
Okay.
So just to emphasize to everyone, if you are replying in the chat, there's a drop down. If it goes to the host, I may not be able to see it. So if you could change the drop down to everyone, that would really help me.
Okay,
Thank
that
you.
might be it. Might be it. Apologies, we're getting to grips with the software here. I'll presume that if you're not interested, you might be thinking about these different courses. And remember, you can transfer from course to course at this stage. Yeah. So it's worth knowing what we're offering. So the 2 design courses are BSc courses. There's product design and engineering product design. And here's the table of courses. We'll just look at that top line really, because that's the 1st year. So for year 1 over here, year 2, year 3 is the placement year, yeah, and then year 4 is the final year. But just look at the 1st year, yeah. The box in red are the common modules. This is where both the engineering product design and product design students will take all of these modules. So a double module in design methods, 1 module in Viscoms and 1 module in CAD. Then EPD will do a module in mathematics and a module intro to mechanical electronic engineering, whereas product design don't do these 2. They do the ones in purple, which is inclusive design and design for sustainable society. So if I show you a little more about what that means, so I said that there are some shared modules, yeah. So for design, in visual communications, in essence, you're trained how to use the Adobe suite. So Adobe Photoshop, Illustrator, and InDesign, and you're able to go and produce presentation images and boards that can be used to go and sell your idea. So this was a collectible toy project aimed at healthy eating, about looking at history and also sold with a healthy eating pack. Yeah. It's also used in things like packaging design, where you're producing the actual design layout for these ones, for the packs. CAD 1, this is an introduction to Fusion 360. So I mentioned that as a Lighthouse account, all of our students have access to all of the Autodesk software. That's free of charge, yeah? And that's used to go and make these solid models, as it's called, where you can produce things. And in the background of that slide, you can see how a student has modeled in blue foam. In this case, it was a torch, and now they're producing the solid modeling and also the internal works of it to go and give the feature construction. So they can go and do the assemblies, the surfacing. You can also work in teams using Fusion, and you can get a bigger result out of it. Export drawings for CAD, etc., and imagery. And this could be one of the things you sell on your placement. You can run this sort of software. In the 1st year for design courses, there's also a module called Design Methods. It's a big module, double module that I help run with my colleagues. And we're looking at how you go about designing things. So creativity, drawing, making in the workshop, lots of projects, whether it's furniture design, whether it is packaging design, and you can see how the drawing and the model making gets linked together to go and give you a much richer result at the end of your project. We also try and bring in live companies for this project. So I mentioned this one in the intro to our presentation. This is with a company called Mojo Nation, and they were looking at a board game with a theme of nature theme. And so one student was looking at, could there be a project based on bees with sort of different roles for the bees, etc. There'd also be a bit of education about saving the bees. Yeah. If those modules are the common modules, I'll just talk about the modules that are specific to first year engineering product design. So first of all, maths. So you will need an A level in maths or equivalent to get onto EPD. And that's obviously the same for Mech Eng and advanced vehicle. And we're looking at just bumping up your mathematical knowledge. So lots of algebra, lots of calculus, advanced geometry, some different equations, complex numbers, because you'll be using them in your other modules elsewhere if they are the engineering modules. And because it's got the word engineering in there, the EPD course title, as you might imagine, there's going to be some engineering in there. So this module covers both electronic engineering, so DC and AC electromagnetisms, and also the more mechanical engineering side, which is forces, stress and strain, dynamics, etc. If you can now remember those common modules that these courses take, for the product design courses, they won't be taking the modules in green, they'll be taking the modules in purple, which is inclusive design and design for a sustainable society. So I mentioned about being a very inclusive university. In terms of design, this is when it means that anyone can use your device. So the first year module for product design they take is inclusive design, looking at ergonomics and user-centered design. So an example of that would be Shenish. She designed an attachment for a one-armed hairdresser. So this would then turn his life around because he could keep on working even with that, perhaps that being differently abled. And product design also do a module of sustainability. We know how key sustainability is. So in this module, the students are looking at the circular economy, sustainable materials, how to make things last longer and be better for the user. As before, all of the coursework, all of the assessment is by 100% coursework. So there are no exams on the product design course. An example of that is Kristin, who was a final year student last year. She was very interested in all sorts of design work. She entered a thing called the Visionaries Competition for a brand new system for packaging contact lenses and came up with a reusable pot you might use. So you might get it posted to you like this. And you might put the empty pack back in the pot and post it back. What's nice about this one is that she won £25,000 February of last year when she won first prize for the actual award. So it's great news, great way of looking at the success of the students. Okay, so look at the B-Eng and M-Eng now. So the B-Eng is a 3-year course, M-Eng is the 4-year course. B is for bachelor, M is for masters. And the mechanical engineering and advanced vehicle engineering are very close. They share the first 2 years. The top of the course is a 1-year course for students with an HND with just for that 1 year. So mechanical engineers, they tend to use a lot more mathematics and science than the designers do to go and solve real world problems. So I talked about this project in the earlier part. This is the belay plate for mountaineers, where the student wanted to replace the metal object, yeah, aluminium, with a polymer object. So it's great because the polymer will be cheaper, lighter, easy to go and carry. But if it was weaker, of course, there's no point having it, because when you're mountaineering, there's a rope going through it. The last thing you want is for it to go and break. So first of all, the student analysed the metal object and came up with a safety factor of 3.3. He then redesigned it in a polymer, realised there was a hotspot of forces over here, and came up with a higher safety factor of 3.6. So now it is cheaper, lighter, and also safer. Yeah, so it's really wonderful. Okay, and so engineers are interested in, you know, how things get put together, construction of them, how they withstand their forces. They're interested in renewable energy and thermal energy, so machines that might, so in this case, maybe a portable wind turbine for campers. So the engineering behind all this, the knowledge of it, how it might be made and also packed up in terms of the extrusions and be able to go carried and moved around. An example of that is Danish's work. He produced a 3D printer that was for chocolate. So at the moment you can 3D print hot polymer. He wanted to go and print chocolate. Yeah, he actually worked for a chocolatier on his placement year. However, chocolate has got some interesting chemistry behind it, and if you don't temper it at the right time, it will appear very cloudy. It'll go white with the sheen. So what he did, he bought the printer, which is the thing below. He then built this tempering system above it. I think there's a slide of him somewhere. Oh, there is. There we go. So there's the CAD model. There's the real model of the tempering system. Yeah. Shellyco Marathon. So for the advanced vehicle engineering students, we run both Shellyco Marathon and also Formula Student. Shellyco Marathon is a very low energy vehicle, so it's very, very efficient. Hence, looking more like this one. Whereas the Formula Student project is a mini race car that races around Silverstone. Sadly, this year that can't happen because of COVID, but it's always an exciting project for students to get involved in. They have a bit of fun with their, their team bonding, etc., and the racing side of it, and they learn a lot from it. I mentioned about how the crossover, of course, happened. So one reason this course occurred rather was that there's always a design project with bicycles or other things in there in the end of year show. So this was a project called Evolve, all about could there be a way of upcycling your favorite bike into an e-bike, electric bike, or could there be a concept idea for a trailer that is also an ambulance for getting through busy traffic. So you might go and cut down that golden hour of getting an injured person into hospital. The structure of the courses. So, oops, wrong way. So this is the structure for mechanical engineering. I've highlighted the first year modules in yellow. So you'll do all of those. They're all 20 credit point modules. You'll get your 120 out of it. If you pass those, you move into the second year. If you pass all of that, you have the option of either going into the placement year or the final year of the B-Eng, which is the fourth year of the M-Eng. And then if you pass all those ones, you either graduate with a B-Eng or you stay on for one more year with us and you do an M-Eng. And the advanced vehicle course is very similar in that it shares the same years 1 and 2. That's a different final year for B-Eng and year 5 for M-Eng. They're doing a module in vehicle and power, dynamics and powertrain. Yeah. What I'll do now, I'll just talk a bit more about the first year modules, a bit more relevant to what you're interested in here for. So I mentioned this a few times already about the mathematics. If you want to be an engineer, you've got to go and handle maths. So we always require an A-level in maths to get onto the course, or an engineering BTEC or equivalent in GNVQ or IB, because you will be expected to go and handle high-level maths pretty much from the day you arrive. Yeah, you've been introduced into MATLAB, looking at matrices and vectors with algebra, more calculus, second-order differential equations, and complex numbers in both linear and quadratic. There's a module in the first year in maths. There's a module in the second year in maths. Yeah, and you'll be using that maths as your workhorse for the other modules as well. We also have a programming module in the first year called Object-Oriented Programming. This will introduce you to C++. So you get to grip some sort of coding aspects. We're aware a lot of you have done some coding at school and college already. this should be at a higher level, so you're able to go and compile tools, edits, and actually design some programs with the object-oriented program, which is a high level, but if you start doing it with it early on, you can then actually sell it into your placement year or your graduate job. As a mechanical engineer, classically you think about things with forces in them. This is our solid mechanics and materials module. This is all about the types of material we have, the engineering material. So I mentioned aluminium, I mentioned polymers already. That's metals and polymers. There's also composites, there's also natural materials. So looking here about how forces and stress and strain, how they react in a structure. Yeah. Also how things move when forces can push things along. Yeah. So looking at material science with some practical labs and laboratories. The other typical thing that engineers do is look at heat and look at fluids. So how we have heat cycles to go and get turbines to electrical generation to go and work. So we're looking at the movement of heat from hot to cold. We're looking at steam cycles, heat transfer, fluid mechanics only on the 2D level because it's quite complex. You get into 3D fluid mechanics later on in the course, looking at boundary layers of enthalpy and entropy. And then last year's module design and practice, where the first year mech engineers are looking at how they can use creativity in engineering, both by sketching, design methodology, and also fusion as well. This course we also use to go and actually introduce students to the IMechE, which is your accrediting body, the Institute of Mechanical Engineers. And also if students do enjoy this module and aren't so happy with the engineering, maths and science, often it's the case they transfer to the EPD course. We can do that if it's done in the first few weeks, of course. If it's too far down the course, you'll have missed lots of key elements. And therefore there's a point that you have to go and repeat the year, but we can discuss that as and when with individual students. Another first year mech eng module is the Intro to Electrical Engineering, where we're looking at the actual physical side of AC and DC circuits, electromagnetism, transformers. Again, there's a few more labs in there looking at control circuits. So you're able to go and actually go and look at the circuit and work out what's what and how it might work and how you might improve it. The last course I'm going to talk about is the top-up course. And this is a one-year course only open to people who've got an HND or they've done 2 years of work elsewhere. So they come into us for 1 year only. Sadly, we can't accredit this course because it's only 1 year. And they will take some modules from mech eng and some modules from EPD. They do a module in manufacturing systems, innovation enterprise, portfolio engineering projects, where they work on the AIM-93 project, thermofluids and turbo machinery, and the engineering project. Okay, we're coming to the end of my presentation now, but not quite. We will invite you all to the Product of South Bank degree show. Presume we've got your email address. This is where we make an exhibition of all the design students' work and also selected mech eng work and advanced vehicle engineering work. And they get to go and show off what they've worked on for their major project. And then the best ones we will take to what's called new designers. Going back to my W5H2, I've done the who's, the where's, the what's, etc. Now I'm on to the when. So you are all in UCAS. Most of you, I think, are called what's called an early applicant because you applied reasonably early. Once you have all of your offers in, you will need to make a decision about which course you choose as your firm choice and which is your insurance choice. Yeah. If you want to go to South Bank, you must pick us as your firm choice. You do that through UCAS. Yeah. If that's done, we then get you on board, and then you'll be enrolled into university probably about middle of August. There's a welcome week about middle of September. That's when you need to be available on campus, because we presume we're back on campus by then, probably with some COVID, COVID secure measurements like wearing masks, etc. Teaching will start late September, and that will run all the way through until the middle of December. And our teaching is split into 2 15-week semesters. So after the Christmas break, you'll have your semester 1 exams. You then go into semester 2, that runs all the way through across Easter until the exam week in May. Why should you accept South Bank as your firm choice? Well, I think I've talked to Alessia about this in great detail, and we think really the key things are that we've got great location. You've seen we're slap bang in the middle of London. We've got a great reputation. You've seen the prize that we've won. You've seen the awards we've been given. All of our courses are accredited. Apart from that one course, but all of the key courses are accredited. We have research that trickles down into your teaching, so you leave us with a good knowledge of where things are going. We've got great workshops, studios, and labs, so you'll be hands-on in the first year onwards. I mentioned the industrial placement year. That means you're very much more likely to be employed because you prove to people you can work in industry. Yeah. And overall, I think it's because it's fun. We put our students first and foremost. You're our key raison d'etre in a way. Some universities are what's called research focused, and the undergraduates are kind of in the way. They, oh dear, you again, yeah. With us, we want you to succeed. We want you to do well on the course, go on placement, get a great job, come back and talk to us and talk to the current students about what you've learned, etc. out there. So moving on to the how-tos now. So the how-to, first of all, you need to firmly accept the South Bank offer. This is the ball's in your court there. We can't do that for you. Yeah, you've got to log on to track once you get all your choices back. Have a think which one you feel best suits you. You've seen how we are very encouraging of the student, got great resources. Yeah, so firmly accept our offer in UCAST. Then go and get your support network in place, by which I mean your student finance and your fees. How are you going to pay for your £9,250 fees each year? Yeah. The placement year, remember, has got a zero fee. That's how much we value that in terms of what it's worth in terms of you getting a better job at the end of the day. Ditto your accommodation, your friends and family. You'll need them to help you realize you're going to be on a full-time course for the next 3 or 4 years. And therefore, suddenly you won't be able to go out every weekend. You'll be doing extra work for us. Yeah. Ditto with part-time jobs. You need to work out how you can go and juggle all your money side so you're not sacrificing a grade over here by having to work a late shift at wherever it might go and be. I'd also recommend that you every day brush up on your maths and science. That's for the engineering courses. Maybe for the design course, that should be brushing up on your designing and your design thinking and making. For both courses, you can download Autodesk 360 CAD software from Autodesk. And there's a free version for you if you go in as what's called a hobbyist. And I'm hoping Alessio is busily typing away here, trying to find the link for the hobbyist. Once you get to university, you'll log in as under our email, and you'll get your free account. If you're using your personal account, they will try and charge you unless you say you're a hobbyist, you're doing it for a bit of fun, and you can go and get yourself a free, I think it's for 1 year at least, version of Fusion 360. Yeah. For all the courses, both design and engineering, take things apart. Look at how they work. Put it back together again. Why does it work even better or worse than last time? Yeah. Once your exams are over, go and look at building a 3D printer. Imagine how much you'd learn by assembling, building, testing. Making your mum a new hook for this, or your dad a new whatever for that, or your carer, something that's broken in the shower room. Yeah. Be on ready for that online enrollment middle of August, because that's when we will actually get you formally enrolled into the university, and make sure you're clear from all of your other commitments, friends, family, stag weekends, hen parties, from mid-September onwards to join a full-time degree course. I think that's almost it. That is. So there is my email address at the bottom, robin.jones@lsbu.east.uk. We've got 10 minutes. Should you want to ask any questions in the chat channel, Alessio is also down there as well. I put down the 2 links for the Instagram accounts. So at Product of South Bank, more design related, and at LSBU MEchEng for more MEchEng related. So I hope you've enjoyed the presentation. If you've got any questions, now it's time to go and ask me or Alessio on the chat channel, and we can actually go and converse and have a chat about them. Anything comes through yet, Alessio?
Nothing yet. Robin, no.
That's
So,
okay.
folks, any questions, please let us know in the chat and we'll answer those live.
So we've got 9 minutes where we need to go off and give this platform to somebody else. I think normal questions are things like fees. So as you know, the fees are the same wherever you go to in England, 9,250. You will need to go and apply to either Student Finance England or find your own way of funding your course. Yeah, but I can guarantee there are very few unemployed engineers and designers because you pick up loads of skills that are very valuable to company. A few students ask about class sizes. So we are lucky we don't have huge classes. You won't be in a class of 300 as you are in some universities. For the design course, there might well be 40 to 50 students in the first year. And for mechanical engineering, 100, 120 maybe. Yeah. So by the end of the first year, Alessia and I will know everyone's name. We'll know a bit about your background. You know, we'll be worried about if you don't see you for a while in class, etc. And you're part of the South Bank family. Often asked is accommodation. Oh, sorry, Leslie, were you saying something?
No, still monitoring it.
Sure. Accommodation, we do have halls of residence. We have 5 of them now sprinkled around the university. If you want to get in the halls, again, you need to apply. You have to get your offer must be unconditional before they'll look at you. So if you do have an offer, I know some of you have, you firmly accept the offer. And then you go and contact the accommodation office and say, look, I'm coming in September, which halls you've got available. For those of you who've got your summer assessments, you won't receive your A-levels or IBs or NDs, BTECs rather, until August. You've got to sit tight until then and then apply for your place once you go and get the grades. We mentioned placement a few times. That's one of our secret weapons, that industrial placement. So you spend year 1 and year 2, where you go and gain your skills, and then year 3 it's your choice. You can go and work in Australia. It's like having a gap year as part of your educational course. Yeah, and you hopefully are using the skills you've learned in years 1 and 2 to negotiate a good salary, etc., and move and come back in the final year with a good project. Alessia, I believe that there was a question.
There was a question, yeah. We got something from Alfie Scrivens. Thank you, Alfie. So what are some of the examples of where people have gone on their placement year for the Advanced Vehicle Engineering course?
We don't make people go on to exactly the same stream they want to. Yeah. So yes, we'd love it if they went to work for McLaren. We have had graduates go to McLaren, which is great. But they could go to either an engineering company in general, or they could go to a supplier for automotive. Unless you know of any, didn't Jack Hayward go on placement?
Yeah. Recently, Jack went on a placement with a company called ASM, based in Weymouth, Alfie. And they design machines for PCBs. So Jack has a passion for electric vehicles. So in that placement, he was learning a lot about the machines that manufacture printed circuit boards, print the flux onto the printed circuit boards, and also the machines that pick and place components onto them and solder them. So although it wasn't a vehicle company as such, it was very relevant to advanced vehicles, which seem to be going down an electric route at the moment. There seems to be a trend towards electric vehicles. So that was in the last academic year, in fact.
It's worth pointing out, we don't give you the place. We don't say your student A, here's placement A, your student B. We presume you will find your own placement. And that may sound a bit scary, but it's exactly the same what happens when you come to your graduate job when you've finished your course. Yeah. However, if you've been on placement for a year, you've got network experience, you've got all these things in your favor. So I'd argue it's incredibly worthwhile doing it because you'll learn lots. Hopefully you learn some money. As you might imagine, the more skills you have, the more money you can go and charge yourself out at. Yeah. If you've been bumping along the bottom of the grade profile, not really trying very hard, why would a company pay a lot for your salary? Yeah. If you've been pushing that boundary elsewhere, you've joined formally a student, you've shown this, you've done that, you've got full A stars, etc. You can then negotiate, well, I think I'm worth more than that, yeah, because I'm working at the same level as someone earning £18,000, £20,000 a year. Yeah. Does that answer your question, Alfie? Any more questions? We've got 4 minutes left before we need to hang up and go. Thank you, Alfie. Another question we often get asked is timetables. So I mentioned that the two BEng, MEng courses have a part-time route and a full-time route. So the full-timers will be in the same class as the part-time students, and they will attend university for 1 day a week. Yeah. So they have a pretty full-on day, almost 9 o'clock until 6 o'clock of studying. The full-timers will join them for part of that course. You'll have one busy day, then you'll have other days as well when you come in there. But we try and give all the students at least 1 day a week where it's free, i.e. there's no classes at the university. That doesn't mean you're out there, down the coffee bar, chasing the ladies, the gentlemen, etc. We're presuming you're doing self-study at home. So you're practicing your equations, you're researching your CAD, you're doing design work, you're looking at your lab reports, etc. Yeah. In the first year, you can get by treating it like a 9 to 5 job. 9 to 5 every day. I do my work at either at university or at home. I have my weekends free and my evenings free. Yeah. Second year, you tend to get a bit more demanding. Sometimes you might need to work a couple of weekends. Yeah. By the final year, people are working flat out. They're working until 7, 8 o'clock in the evening, doing project work, doing research work, doing lab reports, and also a couple of weekends as well. So it is a hard course. Yeah. Engineering design is not easy. Yeah. The flip side is there are very few unemployed BSc product design, BSc engineering product design, BEng and MEng, MEcEng students out there. Okay, Alessia, can you hold the fort 1 second? I need to go and just sort something out.
Yeah, sure, no problem, Robin. So, folks, we've got a couple more minutes. It's been lovely to have you join us today. We're very grateful for your time. Final call for any last question. If not, I'd like to thank you for joining us. We hopefully have come across as a friendly bunch, because we are a friendly bunch, and our colleagues are just as friendly as us. So it's a big decision. You're doing the right thing, joining webinars like this, because you're getting a feel for each respective university.
Yeah.
We think what we're doing is special, and like Robin said, I think the most important point is we put students first, and that's one of our great strengths. We do know you by name by probably the end of the first semester, and you're not just a number on a spreadsheet, I can assure you.
Fantastic. I think, Alessia, we've said everything we need to go and say, apart from maybe goodbye, unless there's any last questions on the chat channel. So thank you very much, Alfie, for being brave and asking that question. Again, thank you for tuning in. Tune to the other universities, see how we compare to them. Ask questions of me on email if you want to. And we hope to see you in September.